physical data independence. It should not harm or it should not change the content of next level if you are making some changes to the low level or a physical level. If there is change in the logical structure of the database, the user view of the data should not change. E.F. Codd was a computer scientist who invented relational model for database management. Hello everybody, a warm welcome to one and all. I welcome you all back to the session 4 and chapter 13, that is database concepts. I am Rohini TS, Department of Computer Science, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. So in the previous session of this chapter, we have discussed regarding the data independence, and that we have discussed regarding the different types of architecture. So if you consider that, there we have discussed regarding the 1-tier, 2-tier and 3-tier architecture. Along with that, we have discussed the topic called database model. So in that it consists of database model theory and database model instance. And also within this database model, we have a hierarchical data model, network data model, and we have a relation data model. This is what we have discussed in our previous session. So in our today's session, we will be discussing about the CODD'S rule. Along with that, we'll see what is this normalization is all about. We'll see the CODD'S rule. So as we all know that database management system, it is a software which will going to manage or which will going to have a communication with the database. So this will going to help us in order to access the content of a database. So that management purpose, so in order to access or in order to do any of the computations, we require one software. That software is nothing but database management system. So in the previous session, we have discussed regarding the relational data model. What is the main thought about that relational data model? Mainly, we are going to consider anything as a table. We are going to represent it with the help of table that consists of rows and column. If it is a row, that is related to record. If it is a column, that is related to field. That is what we got to know regarding the relation data model. What if I wanted to make my database management system to be relational database management system? So it has a capability in order to become a RDBMS from DBMS. That means we can convert any DBMS or a database management system into relational database management system if it is applying or if it is obeying the E.F. Codd's 12 rules. So that is what we are going to learn in our today's session. Mainly he brought 13 rules. So out of that we are going to have all the 12 rules here. E.F. Codd was a computer scientist who invented relational model for database management. So he brought a new thing called relational model. By making use of a relational model, he has managed the database in a proper and efficient and effective manner. So that we have several rules. If you are following all those rules, we can make our DBMS or a normal DBMS into relational database management system. So that based on the relational model, relational database was created. Based on this relational model, we have created the relational database management system. So we'll see the rules about this E.F. Codd's rule. It starts with a 0 and it goes up to rule 12 that you can see here. So totally we have a 13 rules. Rule starts with 0. We'll see about the rule 0, what it indicates. So this rule states that for a system to qualify as RDBMS, if I wanted to make my database system as a RDBMS, then it must be able to manage the database entirely through the relational capabilities. So whatever the data it will going to have. But if I wanted to make my system as a relational database system, it must be able to manage all the database system entirely as a relational capabilities. That means we have to show all the data, whatever is there in the database as a relation that is related to tables. It has to be what a combination of rows as well as the column. That is regarding rule 0. So what about rule 1? That is information rule. Information rule that indicates all the information is to be represented as stored data in cells of a tables. So as the rule 0, we have to integrate or we have to show all the database content as a relation. That means it has to be in the format of table only. But when it comes to the rule 1, information rule, whatever the information we have that we are going to use in order to represent that as a stored data in a cells of table. For example, if you consider this one, so cells will going to be a collision, or cell will going to be interaction between the rows as well as the column. So if you consider, this will be the cell. Whatever the data we have, that data will going to be represented as a stored data in the cells of a table. For example, roll number and their name and their age and their salary. So if you consider any kind of data, it has to be represented with the cells of a table, that is information rule, so that the rows and columns have to be strictly unordered. So rows and column needs to be strictly unordered in order to represent any stored data in the cells of a table. This is related to rule 1. We'll see the rule 2, that is guaranteed access. So we have large amount of data in my database. I wanted to access it. How we are going to access that data? That can be possible with the help of table name plus primary key plus attribute. So primary key is nothing but that represents the row and attribute represents the column. So if you consider a table, consider this as a student table that consists of student ID and student name. Consider the table as a student table. So in this, let me consider 1 and ABC. So this represents the row and this represents the column, right? What is the rule 2 will going to say? Guaranteed access. So each unique piece of data, that is atomic value, which cannot be further divided, that will be considered as what? Atomic value. For example, here I have a student ID as a 1. So I can't further divide this student ID as a 0.1, 0.2. This must be the ultimate value for this student ID. That kind of value will be termed as atomic value. Should be accessible. How we are going to access piece of data? With the help of table name. What is the table name here? Student plus primary key. I have to select which row and I have to select which column. With the help of that, I can get all the data whatever I want. For example, I wanted to know the student ID and name of a student ID called 2. How can I get to know what is the first ID, what is the name of a student ID 1? So for that, I need to take the student table name and then I have to specify which row and I have to specify which column. So with the help of that 3 scenarios, like I have to specify table name and what is the row, that is we have to represent which is the primary key and what is the column. So with the help of these 3 values, we can have a guaranteed access. This is related to rule 2. We'll see the rule 3, that is systematic treatment of null. If I say null, what comes to your mind? Somehow it is 0. But we have several meanings for the null. So that null could be meaningless data, or it can be missing data, or a not applicable data, or no value. Okay. If I say null, that can be not applicable data or no value, or it can be missing data. So there are 3 possibilities for null. But in my table or in my database, if I am considering a null as a no value, then throughout my database, wherever we are going to use null, it has to be no value. And if I am considering a null value as a not applicable value, but throughout the database, it has to be not applicable in all the tables. That is what we are specifying here, systematic treatment of null. For what purpose you are considering null? If you are specifying a null, whether it is related to no value, whether it is related to not applicable value, or whether it is related to missing value. So we have to mention it properly so that it should be handled consistently. Then primary key should not be null. Here I can't take student ID as null, because if I left that student ID, then there will be a missing data. So primary key must be unique in order to identify the content of a whole table. So you should not give a primary key value as a null value. It should never be null. So that expression on null must give null. This is related to rule 3. We'll see about the rule 4, that is active online catalog. If I say catalog, what comes to your mind? For example, you just consider you are just purchasing some of the item, or you are just purchasing some of the product. So at that time, they are going to give you one catalog that is related to how to use the product. In the same way, here also we have a online catalog, active online catalog. So this is also considered as what? Data dictionary. So which can be be used or accessed by the authorized users, and it will going to give us a guidance like how to use the database management system. So this rule states that the structured description of a whole database which needs to be stored in an online catalog, that is considered as a data dictionary. It will going to have a complete structure of a description of a complete database. So like this consists of how many tables, in what table what we have, what are the data we have, which is the primary key, how can I access this element, everything will going to be stored in that catalog, that is nothing but data dictionary. So this can be accessed by the person who are all authorized user. Only authorized users will get to know the complete or a structured description of a whole database. So if it is accessible by everybody, then there will be a no security, then that is also going to breaches the security, so that it can be accessible only with the help of authorized users. That is related to rule 4. We'll see the rule 5 now, that is powerful language. If I wanted to access the content of a database management system, then I require a language. So that is related to SQL, that is structured query language. In order to talk to database management system, I want a language in order to communicate my request to that database. So that one well-defined language must be there to provide all the manners of accessing the data. If I wanted to access any of the data in my database, then we require one language. For example, if we consider the web pages, HTML is a mother tongue for the web pages. So whatever the content that we are going to give in a HTML language can be accessible, can be understandable by the web pages. In the same way, if I wanted to access all the content of a database, then there must be a language. That language is called structured query language. By giving some questions or by giving some queries, it will going to understand what we are supposed to do in a database. So that example for this accessing the content of database is SQL or a structured query language. That is related to rule 5. We'll see about the rule 6 now. View updation rule. What this rule 6 says, all the view that is theoretically updatable should be updatable by the system. If it is happening or if it is applicable in order to upgradable to the theoretical aspects, then it must be able to updatable with respect to the system also. That is the rule 6. We'll see the rule 7, relational level operation. So if I say some of the operation, then it must include insert, delete, update operations at each level of the relations, so that set operations are also supported. So all this, if I wanted to call any of the database as a RDBMS, then it must support or it must allow us to insert some data, or in order to delete the content, in order to do the update operations, and also it has to available and it has to allow us to do the set operations also. That is related to rule 7. We'll see about the rules 8, that is physical data independence. Already we have discussed regarding the physical data independence and logical data independence, right? So if you consider the physical data independence, already I have given you the example. That means what? If I am doing, or if we are doing any of the manufacturing things, or if we are doing some household things which is in the first floor, that should not affect on the second floor. In the same way, if we are modifying some of the content in the physical level, that should not harm or that should not affect on the conceptual level. That is related to physical data independence. So that the physical storage of a data should not matter to the system, it should not affect the applications. So whatever the value or whatever the files or records that we have in a physical data, so that if we are doing any of the changes to that physical data or physical storage of a data, that should not matter for the system, and also it should not affect the applications. So changes whatever we are going to made in a physical level, that should not apply or that should not modify the content of that above level of a physical data. So that is physical data independence. Regarding rule 8, we'll see the rule 9, that is logical data independence. So if there is change in the logical structure of the database, the user view of the data should not change. So that means what? When you are updating any of the software or if the system is getting refreshed, at that time, whatever the view that you have related to the data, that should not get changed. So without knowing to the user, they are going to do the manipulation of a data. That is what? Logical data independence. If it is everything is known to the user or whatever the changes happening inside the logical data, then there will be no security, then there will be no data abstraction. So if I wanted to say any database management system as a relational database management system, whatever the changes that we are making to the content of a logical structure, that should not affect on the usage of a data by the user. That is rule 9 regarding logical data independence. We'll see the rule 10, integrity independence. Integrity in the sense we are checking the truthness or correctness of a data. For example, if a 7-year-old boy or a girl wanted to join second PUC, if they are giving their age as a 7 or 8 years, then the database should not allow them in order to join to second PUC, because 8-year, 7-year or girl or boy cannot join second PUC at that age. So that means we have to check for the truthness of a data. For example, if I am taking more than 10 numbers for the mobile number, excluding country code, at that time the database should not allow more than 10 digits. That is also integrity constraint. We are checking for the truthness of a data. So here integrity independence in the sense the database should be able to enforce its own integrity rather than using other programs. So it must have its own rules and regulations. It should not depend on any of the program. Program could be in any of the language, but there must be some constraints, there must be some rules and regulation in order to maintain the standards of a database management system. So this also makes the RDBMS independent from front end. So it should not depend on any of the program. Other than that, it must have its own constraint. So that means what? You are drawing a boundary to yourself. So then you will get to know what are your limits. In the same way, in the database management system also, it has to have its own features or it has to include their own integrity other than depending on any of the program. That says the rule 10 related to integrity independence. We'll see the rule 11, distribution independence. If I say database management system, at that time the data will going to be distributed all over the world. So whatever I wanted to fetch will going to be integrated together, then we can get the resultant. So here distribution independence, that states that a database should work properly regardless of its distribution across the network. It should not depend on like in which country or in which state the database has been distributed, in what server it is locating. It should not depend on any of the scenarios. So that's what. So this lays foundations of the distributed databases. If it is not affecting where it is located or if it is not bothering about the distribution across the various network, then there will be a distribution independency for the data. Then there will be a chances of getting the data within a few seconds. That means resultant will going to be very fast. So that is related to rule 11. So rule 12 says that non-subversion rule. What it indicates, if low level access is allowed to a system, it should not be able to subvert or bypass the integrity rule to change the data. You just imagine you are in a temple, you wanted to visit a temple. So at that time, so there will be some rules or there will be some special entries, but whoever it may be, they should not take any privileges or they should not get prioritized. So everybody has to go straightly in a queue. That means there should not be any bypass or there should not be any subvert. Then only we can have the integrity for the data. That means we can check the correctness of data. Only every data is genuine. So that is what here. If low level access is allowed to a system, system should not able to subvert or bypass the integrity rule to change the data. For example, if I have accessible to the database or if I have accessible to the content of a database or a file which is in the physical data, then we should not misuse the data, or you should not subvert or bypass the data in order to change the integrity or in order to change the correctness of a data. So that means what? You must be genuine in order to access the content or in order to see the content as it is, even though we have a accessible to the lower level of a system. That means the data where actually it is going to be stored in the database. That says the rules 12. So we'll see the rule 0. Rule 0, that is related to what? It must be able to show as a table. Everything or every content must be in table. Rule 1, information rule should be specified in the terms of cells of a table. And rule 2, guaranteed access. All the data must be accessible with the help of table name, primary key as well as the attribute. Rule 3, systematic treatment of null. So you should consider that null as a missing data, not applicable data or no value throughout the database. And rule 4, active online catalog. So we have to get a structured description of a complete database in the online, that will be considered as data dictionary. Should be accessible only from the authorized user. And rule 5, powerful language. We have to use a language, so that must be enough in order to access the content of database. Example, SQL. Rule 6, view updation rule. Whichever is possible theoretically should be possible in order to make it practical. Next, rule 7, relational level operation. So it has to allow us in order to do the insert, delete, update, some manipulation. Everything has to be supported by RDBMS along with the set operations. And also rule 8, physical data independence. It should not harm or it should not change the content of next level if you are making some changes to the low level or a physical level. Rule 9, logical data independence. So here also it should not change the logical structure of a database from the perspective of user view of the data. And also rule 10, integrity independence. This is related to database management system should ensure their own integrity constraint rather than depending on any of the program. Rule 11, distribution independence. Wherever it will be, it has to be accessible and should be allowed to access the content. Rule 12, non-subversion or rule. So there is no shortcut. If you wanted to access, you have to go straight. That is what rule 12. This is regarding CODD'S rule. So totally we have a 13, that is from 0 to 12. I hope you all understood. We'll see the next topic, that is related to normalization. Why we require this normalization? As we all know that we are, for a database, we are going to collect the data from different sources. So there could be a possibility of having garbage data, there could be a possibility of having junk data, or which is not so necessary for our database. So by this normalization, we are going to filter the data, we are going to segregate the data which is required or which is not required. How we are going to do that? By step by step. That is what we are going to call that as a normalization. So that normalization is a step by step process of removing the different kinds of redundancy and anomaly one step at a time from the database. So normalization is nothing but it is a step by step procedure in order to remove the redundancy. That means if there is more repetitions or if we are having a same copy twice or thrice, at the time we wanted to remove the data from the database, we are doing it step by step. We are removing the anomalies, we are removing the confusions or ambiguity from the database. So if I see database, it has to be pure data. So that means whichever is important or whichever is necessary for the analysis of a data and which should be in the database, for kind of that data only have to be in the database. For that we have a progress, or for that we have a process called normalization. So now it divides a larger table to a smaller tables and links them using a relationships. So instead of taking a complete unit, instead of taking a database as a complete unit, it needs to be divided into some smaller tables. Then we are going to build a relationship between one table to another table with the help of this relationships. And also normalization is a formal process for determining which fields belongs in which tables in a relational database. And also this normalization will going to shows that, or it will going to determines that which field belongs in which table in a relational table, in a relational database. If I have a relational database, then there will be more number of table, and if I say SID or a student ID, that student ID belongs to which table in which of the database. So that will going to be specified with the help of this normalization. And also normalizations rules are divided into following normal forms. So it includes first normal form, second normal form, third normal form, and at last we have a BCNF, that is Boise Code normal form. We'll see each of the normal form one by one. We'll see about the first normal form. What is the first normal form? If I wanted to make my table to be in a first normal form, each cell should contain a single value. So before getting into this, let me write one table. Consider this as a student table. Student, and student will going to have a student ID, and they are going to have a name. Let me consider one more field as a age. So tables are nothing but it is what collision or a intersection of both rows as well as the column. Here I have a 3 attributes: student ID, name and age. So these two are the 2 records. Let me fill the value. So 1 student name, let me consider Suma, here 18. Here also let me consider 1 Suma and 18. What is the first rule? So each cell should contain a single value. So if you consider these are the cell, so that is what intersection of rows and column will be considered as a cell. So each cell should contain a single value. So here if I am going to write one more name called Suma in the same cell, this will not going to obey this rule. At that time we are not going to have the student table in the first normal form. So it should contain only single value. So you should not take this Suma again in a same cell, or else I can't take it 1 1. I have to give only one value, or there must be single value in each cell. That is first rule. Next, each record needs to be unique. So record in the sense rows. How many rows we have here? 2 rows. So all the rows, whatever we have, however number of the records we have, every record must be unique. It should be identical. It should not be same to each other. So that here also student ID is 1, here also 1, here also Suma and age is 18. So this not satisfy the requirement of one first normal form. So that I have to make one more value called 1, 2, and Sunita, let me consider this as a 21. Then we can say that the student table is in first normal form. So let me write it, or let me rewrite it. Consider this as a student table, and it will going to include student ID, and it has name and it has age. So now 1, 2, and here this is Suma and age is 18. Here this is Sunita and age is 21. Then I can say now the student table is in first normal form. I hope you understood. We'll see about the second normal form. What is the first rule it has to satisfy? It should be in first normal form. If I wanted to consider my table to be as a second normal form, then it must follow the first normal form. What was there? So each cell should contain a single value and each record needs to be unique to one another. So second point, partial dependency should not be there. So there should not be a partial dependency between any of the column in a table. Let me consider one example. Consider, so here library ID, and we have student name, and consider issue ID and issuer name, and consider book details or a book name. How many fields we have here? 1, 2, 3, 4, 5. So we have 5 fields, or we have 5 attributes for the table. Okay. So now you can see that student name will going to be depends on this library ID, and this issuer name, those who are issuing the book of a library, then that will going to be depends on the issue ID. But if you consider this book name, that does not depends on this student name. So student name and this book name is not related to each other. At that time, what we have to do, so here if you consider this as a complete table, then there should not be a partial dependency in the table. So we have to divide this table into number of table. That means there should not be partial dependency between one column to another column of a table. So if you consider library ID and issue ID will going to be unique. So this will going to be considered as a primary key. But student name depends on the library ID, and also this issue name depends on a issue ID. But there is no relationship between the student name as well as the book name. Then how we are going to segregate this? We can make this as a 3 tables. That includes, so if I consider a library details, so if you consider a library details, so it only require library ID and student name. So this is related to student details. And also if I consider issuing details, at that time I require only issuing date as well as their issuer ID or their name. And I can have a book details in the table that comprises of library ID and that comprises of issue ID and that requires name of a book, that is book name attribute. So if you see here, there is no partial dependency between one column to another column. So this student ID only depends on the library ID. This issuer name only depends on the issuer ID. And this book name depends on the library ID with issue ID. So there is no partial dependency between this content of a table. So if we satisfy these two scenarios, then we can say that our table in the second normal form. We'll see the third normal form. So what is this? If I wanted to join third standard, then we have to complete first, second, first. So that is what? It should be in second normal form. So if I am saying my table is in third normal form, it has to obey the rules of second normal form. If I am considering that as a second normal form, then again it has to satisfy the requirement of a first normal form also. So it should not have any transitive functional dependency. For example, if you are asking a money with your mom, so your mom should not ask the money from your dad. So that is what you can consider, that if A is equal to B, then B is equal to C, then A is equal to C. But that should not be the case of this normalization. If I wanted to make it what in the third normal form, there should not be transitive functional dependency. So if I consider one example, if I consider one student details, at that time that includes student ID, student name, their date of birth, their street, let me consider district, and their state and PIN. So if you consider this, student ID we have a student name, we have a date of birth, street, district, state and PIN. So as we all know that the street, district and state, all these three depends on a PIN. So there is no third normal form in this particular table called student details. At that time we have to take all these values as a different table called PIN. So how we are going to segregate that? If I consider a student table, at that time the student ID must be the primary key and it includes student name, and I am going to take date of birth as one more attribute and I will consider PIN. So this is related to what? Student details table. And I must have one more table called address details. So in that address details, I am going to take the PIN as a primary key, and I will take remaining attributes as a attributes of this address details. So it includes PIN as a primary key, and that includes street, then it includes district, and also it includes state. This will be considered as one more table. So now we can say that this is in the third normal form. I hope you all understood. Let me meet you in the next session with a continuation of a boys code normal form. Until that, you all keep learning, keep watching. Thank you.